In podcast 84, I briefly described the ideal layout and structure of an oil mill. In podcast 85, I explain how olives are weighed, defoliated, and washed. From this episode onward, I'll start talking about the machines that transform olives into oil. Today, I'll focus on the equipment used to crush the olives. Welcome back to Olive Oil Drops, the first podcast entirely dedicated to olive oil and olives. This podcast is created by Marco Antonucci. This is an English version. I'm Milena. So once the olives have been harvested and carefully transported to the mill, they are selected, weighed, defoliated and washed. At this point, we can begin the process of turning them into oil, a stage commonly known as crushing. Now, in many people's imagination, the process of making olive oil involves two large granite wheels, the millstones, rotating on a stone or metal base to crush the olives into pulp. The pulp is then spread onto woven nylon discs stacked one on top of another and pressed to extract the oil and vegetable water. These liquids are collected and then centrifuged to separate them. Oil on one side, water on the other. The remaining pulp is removed from the discs, which are then washed and reused for another pressing. This traditional method of making olive oil evokes a romantic image of Mediterranean villages and Asian stone presses. But today, only about 10% of oil mills still use this old system. Modern mills no longer use granite wheels. Instead, they employ a crusher made entirely of steel or composite materials that breaks down the olives very quickly. To simplify, imagine placing the olives on a perforated grid and crushing them with hammers until the pieces are small enough to pass through the holes, forming a paste that is then pumped through the pressurized pipes. Well, it may sound less poetic, but in olive oil production, technological innovation has only improved the final product. A crusher essentially consists of a sealed box that can be easily disassembled for cleaning and maintenance with two openings, one where the olives enter and another on the opposite side where the crushed paste exits. The olives typically enter after being washed and defoliated, though, as we'll see in future episodes, they may sometimes undergo additional treatments such as drying or pitting. Inside the box is the crushing mechanism, and crushers are classified according to the type of mechanism they use. Before explaining how the most common models work, let me make an observation. The crushing mechanisms are powered by one or more electric motors whose strength depends on the machine's capacity. 20 years ago, their rotation speed was fixed by the manufacturer and could not be changed. Today, that is unthinkable. There is no crusher which cannot have rotation speed adjusted. So the first type is a disc crusher. It isn't very common and is best suited for olives that can be processed at relatively low speeds, around 1400 revolutions per minute. The olives enter through a feeding system, usually a screw conveyor, which pushes them between two flat-toothed discs, one fixed, one rotating. The process is similar to grinding coffee in a cafe, where beans drop into a hopper between two discs and are ground to the desired consistency. The operator can adjust the fineness of the grind by changing the distance between the discs. The same applies to the disc crusher. The operator can adjust the crushing level during operation without stopping or opening the machine. This system offers several advantages: continuous adjustment of the crushing degree, low paste heating, reduced water oil emulsification, and enhanced oil pigmentation. Then there is a roller crusher. At first glance, this machine looks like a large pasta roller. The olives enter through a feed unit that pushes them between two or more rollers, which rotate slowly. These large stainless steel rollers have grooved, helically toothed surfaces. The distance between them can be adjusted to control the coarseness of the crush. One roller is mounted on springs to prevent damage from any uncrushable objects, such as stones or bits of metal. This method does not heat the olives, does not cause water oil emulsions, and produces no steam. Then there is cone crusher, now largely obsolete. This model is a sort of hybrid between a disc and a roller crusher. It consists of a conical housing with internal grooves and a rotating metal cone covered with long, rigid teeth. These olives are pressed between two surfaces, somewhat like a citrus juicer for olives. Then there is knife crusher. Picture a 1960s table fan with three offset blades enclosed by a fine metal grid. Like knife crusher is somewhat similar in design. It is a closed box containing a rotor with multiple blades or knives rotating at moderate speed, around 1600 revolutions per minute. The knives come in different shapes and sizes, often hollow and mounted helically relative to the grid. Their function is to chop the olives into pieces small enough to pass through the grid holes naturally without compression or heating. The grid resembles the drum of a washing machine. Some manufacturers make the holes slightly flared to help the paste flow through. The holes typically measure between 5 to 8 millimeters in diameter, but can be changed as needed by replacing the grid, a task that requires stopping and opening the machine. Some models may include a pre-crusher, which coarsely breaks the olives before they reach the knives. Increasingly, rotating blades with built-in sprayers or mechanical cleaners are used to allow quick, continuous cleaning between batches. And then there's hammer crusher. This is the most widely used crusher, offering high production capacity, uniform crushing, mechanical reliability, low maintenance, easy cleaning, and compact size. A screw feed pushes the olives into the crushing chamber with a rotor with 3 or 4 hammers, blades fitted with heavy, very resistant metal plates, spins rapidly, striking the olives against the surrounding grid. The hammers can be fixed or swinging. The fineness of the paste depends on the size of the holes in the interchangeable grid. Once crushed, the paste passes through the grid and is pumped or conveyed to the next stage, the malaxation process. The rotation speed is higher than in other systems, reaching up to 2800 revolutions per minute. This results in faster but also more aggressive crushing with both positive and negative effects. To balance this, some manufacturers use a two-stage grid system, the first with larger holes between 10 to 12 millimeters, the second with standard ones 5 to 8 millimeters. As with other crushers, the grids can be replaced at any time after stopping and opening the machine. Which one to choose? We'll talk about that in future podcasts. If you wish to ask us questions, you can do so either by email, oliveoildrops@gmail.com, website www.oliveoildrops.com, where you can also find text of this podcast both in Italian and English, or comment space of the podcast platform you have been using and to which you can subscribe free of charge. Thank you for tuning in today.